is Mr. Ring going over quiz number 3, taken October 23rd, 2018. This is version B. Determine whether the relation in question number 2 represents a function. So in question number 2, here it is. Look at it. You'll recognize that it passes the vertical line test, and the answer is yes. Every ordered pair is 1 to 1. There's no repeating x values. Question number 2, use a graph to determine the function's domain and range. Domain goes from left to right, and then range goes from bottom to the top. So domain from left to right starts here, starts at 0, and the last thing you touch is an arrow. So that means infinity, positive infinity going that direction. So this one works, this one doesn't, this one does, this one does. The range goes from bottom to top. It's not touching the graph. It's not touching the graph until y, the y values, are at -1. And then goes to, last thing it touches is infinity. So -1 to infinity. So no, yes, yes, no. That one said 0. So the answer is C. Question number 3, determine whether the given function is odd, even, or neither. You can test this algebraically. So every x value you're going to put a -x. -x to the 5th power, this whole thing is just going to represent -x to the 5th power. -x to the 3rd power, you're writing out -x times -x times -x, and that'll be -x to the 3rd power. So when you multiply those, there'll be a positive x to the 5th minus x to the 3rd. I'm going to factor out a -1, or negative, so the opposite of a positive number is a negative. And the reason I'm doing this is that you'll recognize that every time I see x to the 3rd, -5x to the 5th, I can write f of x. So let me go ahead and write f of x here. And that means we have the opposite of the original problem, that is odd. Question number 4, how is question number 5 bounded? So if I put number 5 into my graphing calculator, and I might as well just answer question number 5 right now. So if I put that into my calculator, x to the 4th minus 16x squared plus 20, and I press zoom 6, you get this graph. And it doesn't really go well. You see how you can't find the minimums and you can't find the maximums? So if you change the windows here, this is an x minimum, x maximum, so -3 to 3, -3 to 3. Press graph. What that graph did is it actually zoomed in and it made it worse. Okay, so that one doesn't work. And if you do zoom 6, that's a -10 to +10. I can't see all of the graph. Let's try -50 to -50. When you have big values like that, I would do the scale by tens. And it's too small. So let's try this one. -5 to 5, and -50 to 50. Here I'd count by ones, count by tens. That's a nice graph. So that would be D. Going back to question number 4, now that I have a graph on here, the graph looks something like a W. You'll notice that it is bounded below, because the graph doesn't go anywhere here, and it's unbounded, no boundaries above. This one says bounded above, unbounded below. This one says only bounded below, so I would pick that one. Oh, only. Only bounded below. Yeah, it's only bounded below, and it's not above, so I would do K. And let's go to the back side. So if I put in -x for every x value, then -5 times -1 to the 5th power is still a negative. So this becomes just -x to the 5th power. This is becomes -x to the 3rd power. So negative times negative is a positive. you'll notice that this problem looks like the original, but here I'm going to factor out a -1. So now I have x to the 5th plus x to the 3rd. Does that make sense? Because you can distribute this negative sign to be negative x to the 5th, and that becomes, what happened? This should be negative. No, that's a positive. Negative. So that becomes negative times negative is a positive, and negative times positive is a negative. And so if you do that, you are going to get, what happened? Negative times negative is a positive, 5x to the 5th minus x to the 3rd. If you factor out a negative, negative x to the 5th plus x to the 3rd. Okay, that's what I want done. And then here, every time I see negative x to the 5th plus x to the 3rd, I can just put in f of x. So basically we have the opposite of the original function. This is odd. Question number 4, how is question number 3 bounded? So if you look at question number 3, this one, put into our graphic calculator, negative 5, x to the 5th plus x to the 3rd, zoom 6. Let's take a look at this graph. They call this an odd degree function. So notice how arrows and arrows. So it would be unbounded above, unbounded below. So unbounded above, unbounded below. So that would be none of the above. And the last problem, use a graphing calculator or computer to determine which of the given viewing angles produces the best graph. So we'll put that into my calculator. X to the 4th minus 16x squared plus 20. Zoom 6. Whoops. What happened there? That should be a minus, so delete that. Alright, let's graph it. Notice here we can't see the minimums, and we can't see a local maximum there. So I'm going to zoom out. And if you check all of these, you'll notice that the best one is probably going to be D. So we go to Window. X minimum is -5. X max is 5, -50. 50. Here I'll count by tens because you have such a great range there. And then graph. And this produces the best graph because now I can see the minimums and the maximums. So D is the correct answer. Alright, let's go over some multiple choice from version A. I noticed that this student, although they graphed it, doesn't, I don't think they saw right here that it should have been repeating x values. That's why it's not a function. This one here looks like a better graph of these. You can kind of see that it doesn't pass the vertical line test there. The student graphed them correctly, but didn't realize the vertical line test here. Question number 2 here, the student wrote domain is left to right, range is bottom to top. Got that correct. So, and they even put a bracket right here to show that it's a closed circle. This student drew a visual of the domain and range. Very helpful. Alright, for question number 3, the student substituted negative x. Recognize negative x to the 5th. They should have just simplified and then just see if you can just factor out a -1. Student simplified, but should have factored out a -1 here. Here the student recognizes after you substitute negative x, factor out a -1 is the opposite of what we started with, which is odd, which is correct. Alright, for question number 4, how is question number 3 bounded? So if you took this is an odd degree function. So it's like a linear, which means that they're going in different directions. One starting, in this case, you'll start up and down. This one has 2 different arrows, so they could have just used their graphing calculator to put that in and get a visual. If you recognize that this student drew the graph and then they wrote unbounded above and unbounded below, so the correct answer is L. The student here could have just graphed it and then changed the windows to see which of these four would have given the best. Question number 6 says graph the following function, x cubed minus 5x squared plus 9. Just put that into your graphing calculator, and then you get the sketch here. And then what you could have done is just use the calculate button to calculate your maximum and your minimums. Once you do that, just write down the order pair 0, 9, 3.3 to negative 9.52, and then this problem for question number 6, B and C. So you got 2 points just for a correct graph. I give you 1 point if the arrows are facing both up, and then I ask you where's it increasing. Well, if you look at it, from left to right, it's going up here and in this section. So this is from the negative infinity to this value on the x-axis, which is 0. And then it's increasing from 3.33. We said in our class that this is not increasing nor decreasing. So from here, it's a parentheses 3.3 to the going towards the right, which is an arrow, which is a positive infinity. And it's only decreasing between here, which is 0, to 3.33 on the x-axis. These were 1 point apiece. For question 7, it says find the domain algebraically in interval notation. So you have a square root problem here, and algebraically means here you have three options. In class we talked about either setting it not equal to 0, greater than or equal to 0, or greater than 0. In this problem, I can make it greater than or equal to 0. The reason why I can do this is because I can have a square root of 0 or a positive number, but we cannot take the square root of a negative. It becomes complex. So I set it greater than or equal to 0, add 3, divided by 4. Now this says interval notation, so greater than 0 is including, closed circle, going towards the right. So this would be a bracket, 3/4, comma, or 0.75 to infinity, parentheses. That would be interval notation for, I believe, version B. Version A, they ask you for set builder notation. So we can have all values of x such that I should have all real numbers in there, comma, no, take that back. X, all values of x such that you're just going to take your inequality here and put it there, which is x is greater than or equal to 3/4. You got 2 points if you set it greater than or equal to 0. I got the rest of the problem wrong. If you got not equals to 3/4, I gave you 2 points. I gave you 3 points if you wrote x is greater than or equal to 3/4, but did not put it into set builder notation. This is version B scanned. And then if you got x equals 3/4, same thing, I give you 3 out of 4 points. Let's look at some student work. Okay, here they drew a correct graph, but from the graph, they could have actually labeled their ordered pairs. And so here they wrote it negative infinity is correct to 9. They wrote the y axis. This should have been the x-axis, which should have been 0. Again, although your y values tell you how high it goes, this is the maximum. We're not looking at the y values, we're looking at the x values for increasing and decreasing. Alright, so this student got a 2 here and a 2 here. They color-coded it. So again, if it helps you, you can get it to the, you're looking at the x values. So increasing from here to there, decreasing in the orange, and then yellow is increasing. Alright, students squared it. They were not supposed to set it not equal to 0, but I gave them a 3, it looks like. X not equals 3/4, because you could put 3/4 in there. 3/4 times 4 gives you 3. 3 minus 3 is 0. Square root of 0 is 0. And then also they missed that they wrote this in interval notation, not set builder notation. Well, what happened here? Looks like they squared on both sides to get rid of it, but then they also squared what's inside. Incorrect. I think the student here tried to square root 4x got 2, square root of 4 is 2, and then square root of 3 is approximately 1.7. Remember, you're trying to find the domain. Domain is just x values. What kind of x values can I get algebraically? Again, this student wrote it in set builder notation. It's supposed to be in set builder notation, but they have an interval. Whoever's paper is this one, that should get is 1. I think I just looked at this, but shouldn't have gotten a 3. Because you can't take the addition property of equality through the square root. They should have squared both sides first, so this is totally wrong. For question number 8, it says find the x and y intercepts for the following function. You have f of x equals x plus 1 over x minus 5. The x-intercept means make y equals 0. There is no y variable here. That's the f of x. And then if you put in 0 here, you can make 0 fraction, 0 over 1, cross multiply. And then 0 times anything is 0. 1 times anything is that anything, which is x plus 1. To solve it, you subtract 1, and you get x equals negative 1, which means the order pair is negative 1, comma, 0. Y-intercept, x is equal to 0. Put in 0 for my x's here. You get 1 over negative 5. 0, comma, negative 1 over 5, or negative 0.2 would have been correct. 4 points if both of those correct. 3 points if one's correct and one was close. And 2 points if just one was correct and the other one's way off. A common mistake was to write x minus 5 is not equal to 0 or equal to 0, thinking about the denominators. But the denominator, to find the domain has nothing related to the x and y intercepts. Let's look at some student work for question number 8. Here the student correctly found the x and y intercepts, but I boxed theirs, so they eventually lost a point there. Good job here, finding your y-intercept and x-intercept. Okay, the student found here, they put the two order pairs together. So here you made the y equal to 0, and then this should have been a negative 1, x equals negative 1 comma 0. But they kind of combined it together, and they found 1/5 over here by substituting in 0 for x. Should have been negative 1/5, but you don't combine them together. It should be two separate order pairs. Alright, question number 9. To make sure to include the asymptotes and table of values, and also graph it. So how do you get a graph? Well, first I'm going to find my vertical asymptotes. I'm going to set that equation here not equal to 0. If you add 5 to both sides, x is not equal to 5 is my vertical asymptote. My horizontal asymptote, if I look at the highest degrees here, it's just really x divided by x. That means that the exponents, right where my cursor is 1 and 1 right there. So that means you reduce. So you get 1, y equals 1. And I put that on my graph here in the blue, and my vertical asymptote here in the pink. To create my table of values, I'm picking numbers to the left of negative 5. Sorry, positive 5. So 1, 2, 3, 4, kind of leading up to that here. And then I'm picking values that are higher than 5, 6, 7, 8, 9, and writing those values down. And just graphing those ordered pairs, and you'll see my graph gets into this quadrant here and this one. And you'll notice a lot of times, not all the time, that your rational functions are smooth curves on the opposite sides of one another. I awarded you 2 points for a correct, accurate graph, and then 2 points for an accurate vertical asymptote, horizontal asymptote, and table of values. And then there's one question, I don't know if you realize it was there. Looking at this graph here, is it continuous or discontinuous? The answer is discontinuous because I have to pick up my pencil to draw the rest of the graph. Well, if discontinuous, what type? So if you just wrote discontinuous, I gave you 0.5. To get the 1 point, it's an infinite discontinuity. It's infinitely there. You will not pass. Let's look at some student work. Right, so the student got the horizontal asymptote correct. They wrote down even the steps for vertical, but they try to cancel those, but you can't because they're not identical. Okay, here's a good looking graph. Table of values looks good. Found the horizontal asymptote and vertical asymptote looks good. Alright, in this problem, it looks like they have a table of values and then they kind of sketched it. I only gave them 1 point because it looks like they just took it from the calculator because their table is incorrect. They got 0 there. Asymptotes are wrong. Doesn't even have it. Here has a no table of values. That's why I circled at 1 point. Maybe they got that graph from the graphing calculator. They at least had the horizontal asymptotes. I identified that by putting a check there and give them some credit.
I love math. You don't love math? What's wrong with you?